now we're going to look at a correlation analysis. So it's important to realize that a correlation analysis only finds a significant relationship. So if I'm looking at two continuous variables, all this does is say they're related and they're significantly related. So this is not as powerful of an analysis as a linear regression because I'm not able to predict, I'm not able to get into the specifics of the relationship. I'm solely able to say, yes, these things are related. And in this packet, we're going to look at the Pearson versus Spearman's correlation. Pearson is for linear, Spearman is for nonlinear. And so if we have a relationship of -1 is a perfect negative linear relationship. So the closer it gets to -1, the more of a strong relationship is present. And what it means is that as one variable increases, the other variable is going to decrease. If we have close to a 1 or a +1, this would be a perfect positive relationship where both variables increase together. So as one variable goes up, so does the other. The closer the value is to 0, the weaker the relationship, with being exactly at 0, meaning there is no relationship. So ideally, we want something like -0.75, +0.8, because we want to be as close to that 1 and -1 as we can be. So our example research question is there a statistically significant relationship between my two variables? Where my null hypothesis is that there is no statistically significant relationship between those variables, and my alternate is that there is a statistically significant relationship between those variables. So now we're going to look at the assumptions for Pearson versus Spearman correlation and how to check them. So the first assumption, there's nothing to do in SPSS. You're just saying that these are continuous variables. And what I mean by that is they are scale variables within SPSS, which means they are numbers, they are quantitative, they are not categories. So something like an exam score, a study time, a weight, a height, a age, anything that is a measurable and meaningful number is going to meet that assumption. And so you're going to explain that these are measured on continuous scales, meeting the assumption for the correlation. Now, the next piece is where Pearson and Spearman are going to deviate. So the next assumption you're going to check is you're going to look at the assumption of linearity. And to do that, you're going to have to generate a scatter plot. And so what I have done is I've put a appendix in with how to run the actual scatter plot at the end of this packet. So if you go towards the end of the packet, in order to check this assumption, you are going to have to generate a scatter plot. So you're going to follow these instructions in SPSS to generate that scatter plot. Once you generate that scatter plot, you're trying to determine if there's a linear or a nonlinear relationship. And so here's the examples of the linear relationships in that scatter plot. And it doesn't have to be a perfect linear relationship like these, but it really just can't have any kind of curvature to it. Like that's the key piece, is that we can't see that kind of curvature. And while you're in that scatter plot, you're going to want to know if it's positive or negative. So I've given you kind of a look at a positive correlation goes up from the left to the right, and a negative correlation goes down from the left to the right. And so this is kind of where the division comes up. If there is a linear relationship, you keep going, it doesn't violate it. If there is not a linear relationship, then you have two options. The first is to transform your data, which is admittedly the harder thing to do, so this is not what I recommend. What I do recommend is just using the Spearman's correlation. It's a different checkbox that I've indicated, but it works, everything's the same, you just check a different box. So this is kind of what I recommend. So for our APA write-up, we've got this here. We've got the scatter plot indicated a linear, nonlinear relationship. that is positive, negative, thus either satisfying or not satisfying the linearity assumption. And here you're going to need to cite a textbook. So your SPSS book is a perfect textbook to cite to let people know that that's where you're getting the assumption from. I have some more information on dealing with nonlinearity, but basically here's what it comes down to. If it's nonlinear, you do Spearman's. This is kind of an advanced reasoning that I left in here, but for the most part, I would skip over this part of the packet and I would just go to Spearman's. Then we're going to test for outliers. So we're not going to go directly into Spearman or Pearson. We still have to test for outliers. Remember, the way that we test for outliers is by looking at those box plots, but they are generated at the same time as testing for the next set. What I have done is I have looked at, they are there to look at a box and whisker plot, and there are some options for outliers. So if you identify there are no outliers, you just keep going. If you identify that there are outliers, you should check your data just to make sure you didn't mistype something, because that's actually very common. You need to determine, could someone have mismeasured that outlier? So did something happen during testing? Is there anything that could account for it? And then you're going to decide, if this is an actual outlier, do I keep it, do I change it, or do I remove it? And really, that's going to be up to you to decide, and you just need to own that decision for why you did that. So a lot of times, if we keep the outlier, what's happening there is we're saying, hey, this is a true outlier, and in order to really understand this test and the data, I need to keep the outlier in. It's really rare to transform the data unless we're transforming all of it for a reason. We don't typically want to decide this. And then removing the outlier would be if maybe you've got 100 plus data points and there's one or two outliers, removing those is not going to significantly impact the data. So you can remove those. The really key piece of that decision is you need to have enough data to be able to remove it. So then I move into the Shapiro-Wilk, and if I'm looking at a Shapiro-Wilk, it will generate the outliers as well. So you will need to look at this and generate the outliers, and I'm just going to put a note to see the appendix for how to run this in these areas. So we've got, then we have the assumption of normality, which is our Shapiro-Wilk test. And so again, we're going to go to the appendix, and that's going to run Shapiro-Wilk, and I've given you how to decide if it's normal. If the p-value from Shapiro-Wilk is greater than 0.05, it is normally distributed, it meets the assumption, you're good to go. If it is less than 0.05, it does not meet the assumption. It is not normally distributed. And so at this point, even if you found that it was linear, you might want to use Spearman's instead of Pearson. And that's just a decision you're going to have to justify. And so again, if we go down to that appendix, this is my outliers in Shapiro-Wilk. You will run this test before the correlation, but after the scatter plots, and then you will follow these steps to determine what the outcome is for that. So once you have checked the normality of variables, you are then ready to do your correlation analysis. And so I've kind of written out what to do, as well as giving you pictures of what to do. So you're going to go to Analyze, Correlate. You're going to go to Bivariate. You're going to move your variables in. And then I have a note here. If linearity is violated or normal distribution, then I want you to check Spearman. So if your linearity was violated or your normal distribution was violated, you're just going to check off Spearman to use that output. Then I have interpreting the output. So you get a descriptive statistics table, which is nice because it will tell you the mean value for each variable, the standard deviation, and then the number of data points. You need to report the descriptive statistics in addition to the correlation. If you're looking at Pearson, this is the table that it gets you. This information under Math Achievement Test is going to have the values twice. So you're only ever going to look at the right-hand side, top two here. And so if I look at this, I have a relationship of 0.338 and a significance of 0.003. So I would report this as my R for 73 is equal to 0.34, because I would round, with a p-value of 0.003. That 73 is coming from n minus 2. So I had 75 minus 2, which is 73. That is going to be the piece that you need to look at because that is talking about it. So I have a positive relationship because that R is positive, and I have a significance of 0.003. If you checked off Spearman's, it's very similar. You're still just looking at these top two areas, and it's just a different table. So if you're doing Spearman's, it doesn't change anything. It's still going to be that n minus 2. It's still going to be that top row, and then that's still going to be that second row. And so how do we interpret this? So if our R value is between 0.1 and 0.3, it's going to be small. If it's between 0.3 and 0.5, it's going to be moderate. So if I look at this one, I have 0.32, which is moderate. Or if I looked at Pearson's, my example had 0.34, which is still a moderate relationship. And this doesn't speak to positives or negatives. This is just purely whether it's positive or negative, and it's between these values. If my p-value is less than 0.05, the correlation is statistically significant. So even though you found a moderate correlation, that p-value being less than 0.05 means that it's significant. So don't get caught up in the fallacy that only strong relationships matter. Something that is moderate can still be statistically significant. And then we have the positive. So because our R value is positive 0.32 for Spearman or 0.34 for Pearson, that means that as the achievement test goes up, so does mother's education. As you look at a mother's education, the more education they have, and that's what I mean by it goes up. So the more educated the mother is, the better the math achievement scores are. And so that's what it's really telling us. And so here is just a very basic APA write-up here that you would want to use. And you would say a Pearson or a Spearman, just depending on which one you went with, depending on your assumptions and your linearity. And you're going to report this out. I have an expanded write-up here. We don't really care about the confidence intervals, so I'm just going to remove that part. I have this as the standard write-up, kind of an APA formatting, and then I just have some common issues that you can find. So that is how you look at a correlation and how you run the correlation for your data set.